Hi everyone, welcome to all 4C learning classes. This is session 8. So, according to Fisher and Race nomenclature, a pair of homologous chromosome 1 will have the 3 loci in each chromosome. There are 3 loci where the presence of C, D, E alleles are going to be playing vital role. So, what we discussed is the 3 loci are 3 different loci. Look at here in the a pair of chromosomes where here either capital C or small c, capital D or small d, capital E or small e. So what are all possibilities of the genotypes we find? It is capital C, capital D, capital E. So this indicates all the 3 dominant alleles, whereas here small c, small d, small e. Next, there is a possibility of capital C, capital D and small e, capital C, capital D, small e. And another is capital C, small d and capital E. Look at here. Next, it may be with capital C, capital D, capital E and capital C, capital D, small e. Right? And it may be capital C, small d, capital E and capital C, small d and small e. It can be small c, small d, capital E. Next, capital C, small d and capital E. Look at here. Or else the small c, small d and small e. Why I have changed here is there should be different types of the genotype. These are all what are different possibilities. Look at here. Here what I told you is according to Fisher and Race nomenclature, presence of a capital D is going to be determining an individual Rh positive. So here, look at here, this is what taken into consideration, capital D, small d. Next, capital D, small d. Here, capital D, capital D. Here, small d, small d. Here, small d, small d. In order to take into consideration, in order to determine an individual Rh positive or Rh negative, look at here. Here, capital D, small d, capital D, small d, capital D, capital D, small d, small d, small d, small d. What you have observed is presence of a pair of chromosome with capital D, small d, capital D, small d, capital D, capital D. All these 3 individuals are Rh positive. So by this you come to know an individual with a genotype capital D allele determines Rh positive. An individual with the double recessive condition, what is a Rh negative individual, Rh negative. So this is what the description regarding the Fisher and Race. According to Fisher and Race, presence of capital D, what determines an individual Rh positive, and this is the most commonly following the method of nomenclature. The another one we see is Wiener method of nomenclature. Wiener method of nomenclature. Pause it. Now we'll go for the Wiener method of nomenclature. So according to the Fisher and Race, presence of CDE nomenclature, which is determined a person is a Rh positive. and double recessive small d is a negative. In the same manner, now we'll go for the another method of the Wiener. According to Wiener, what Wiener proposed is there are the 8 alleles present in a single loci. 8 alleles present in a single loci means the place where a gene is present. 8 alleles are responsible for the Wiener nomenclature, where the dominant alleles are R, R1, R2, RZ and RO, and recessive are small r, small r1, small r2 and small ry. So calculate 1, 2, 3 and 4, 5, 6, 7 and 8. So presence of 8 alleles in a single loci determines an individual RH positive or RH negative. There we see capital C, capital D, capital E, small c, small d, small e. So C, D, E nomenclated that. Here it is capital R, small r. They are 4 plus 4. 4 dominant alleles, 4 recessive alleles. It is R1, R2, RZ, R0 and small r, small r1, small r2, small ry. 8 alleles in a single loci determines the RH positive or RH negative according to Wiener. It is of homozygous and heterozygous, dominant and recessive. So a person will have all these 4 is going to be determine the RH positive. Presence of capital R is going to determine an individual RH positive, and presence of the recessive allele, double recessive, the same thing, which means R1 is RH positive, R1 R2 capital R existence, presence of capital R is RH positive, double recessive, which means small r is RH negative. In the same manner, R1, R2, RY, so double recessive is RH negative. Here R1 is RH positive, R1 R2, but capital R is RH positive itself. Capital R1, capital RZ, RH positive. Capital R1, capital R0, RH positive itself. So presence of capital R, whether it is a dominant sense homozygous or heterozygous. R1 is a homozygous itself. R2 homozygous, but R1 and R2 it is also dominant, and capital R1 and small r, it is heterozygous dominant. So this is how we see the genotypes. Presence of capital R is going to be RH positive, whereas double recessive is negative. In this connection, one point let me recall you. If the number of alleles are 2, how many number of the genotypes we have observed? That is, if the number of alleles are 2, the number of genotypes are 3, which we have done based on a mathematical expression n into n plus 1 by 2. Is it right? Yes. N into n plus 1 by 2 is what we see is a mathematical expression, a formula to determine the number of genotypes. So in this connection, we do also see such type of the genotype. So number of alleles are 8. 8 into 8 plus 1 by 2. So it is 8 into 9 by 2. So 72 that by 2, that is none other than 36 number of genotypes. And that I will show you here how the such genotypes can be. 36 number of the genotypes according to Wiener. Right. So R1, R2, RZ, RO. Small r, small r1, small r2, small ry. So how many they become? 8. So total number of genotype, let's see. Capital R1, a condition exists. Each gene is with the 2 alleles. So this is 1. Next, capital R1, capital R2. 1 homozygous. This is also homozygous itself, but different alleles dominant itself. So capital R1, capital RZ, capital R1, capital R0. I repeat, R1, 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 R2, R1, RZ, R1, R0. 1, 2, 3, 4. Next, heterozygous possibility is there. Capital R1, small r, capital R1, small r, capital R1, small r1, capital R1, small r2, capital R1, small ry is what we see. So the number will be 1, 2, 3, 4, 5, 6, 7, 8. Next, capital R2, capital R2, capital R2, capital RZ, capital R2, capital R0, capital R2, small r, capital R2, small r1, capital R2, small r2, capital R2, small ry. 1, 2, 3, 4, 5, 6, 7. R2, 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 RZ, R2, R0, R2, small r, R2, small r1, R2, small ry, R2, small r2 and small ry. Next, RZ, 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 R0, RZ, small r, RZ, small r1, RZ, small r2, RZ, small ry. Look at here. 1, 2, 3, 4, 5, 6, 7, 8. R0, 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 small r, R0, small r1, R0, small r2, R0, small ry. 1, 2, 3, 4, 5. Is it right? R0, R0, homozygous. And now it will be heterozygous. R0, small r, R0, small r1, R0, small r2, R0, small ry. Next, small r, small r, small r, small r1, small r, small r2, small ry. So you have to take all possibilities. Next, R1, 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 R2, R1, R2, R1, Ry. Next, R2, 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 Ry. Then Ry, Ry. Look at here. 1, right? 1. Then here 2, right? Next here 3, 1, 2, 3, right? Next 4, 1, 2, 3 and 4, right? Next 1, 2, 3, 4 and 5. Next 1, 2, 3, 4 and 5, 6. 1, 2, 3, 4, 5, 6. Next 1, 2, 3, 4, 5, 6 and 7. Next 1, 2, 3, 4, 5, 6, 7 and 8. Okay, this is a clear evidence. If the number of alleles are 1, 2, 3, 4, 5, 6, 7, 8, the number of genotype 8 into 9 by 2, 8 9 is 72 by 2, 36. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Right? So these are, if the number of alleles are 8, the number of genotypes are 36. We have calculated if the number of alleles are 2, capital T and small t, 2 alleles, number of genotypes will be capital T, capital T, capital T, small t and small t, small t. Is it clear? Right? Number of alleles are 3, we have seen IA, IB, IO, 3 alleles. Then what will be the number of genotypes? 3 into 3 plus 1. 3 plus 1 is 4 into 3, 12 by 2, 6. So the genotypes is for A, recall your memory, IA, IA, is it right? Or else IA, IO, B, IB, IB, and IB, IO. Next, AB, IA, IB, and O, IO, IO. Right? So 1, 2, 3, 4, 5, 6. If the number of alleles are 3, number of genotypes 6. If the number of alleles are 8, the number of genotypes will be 36. In this connection, what is RH negative? This is very, very important point. That's the reason why this entire description we have seen. This whole the summary what give you who are RH positive and who are RH negative according to Veena. So the number of possible genotypes are 36. In this, look at here, double recessive. Is it right? Double recessive. So all these are what are considered to be the RH negative. RH negative. Is it clear? Right? How many are RH negative? 4 plus 3, 7 plus 2, 9 plus 1, 10. So RH negative will be 10. So out of the 36, number of RH negatives are 10 and RH positive will be how many? Out of 36, 10 are RH negative and the remaining 26 are 8 plus 7, 15 plus 6, 21 plus 1, 20 plus 21 plus 5 is 26. So 26 are RH positive. Remind you, this is how we come to know the RH positive, RH negative. This is what we see. Now let's come to discuss what is the consequences. Already I told you RH positive, RH negative are phenotypically normal, whereas blood transfusion so blood transfusion and the pregnancy individuals are prone for consequences. The consequences need to be HDNB or else hemolytic disorder of newborn. I repeat, the blood transfusion, RH positive, RH negative individuals are phenotypically normal, whereas RH positive blood group if transfused to RH negative individual, or else the pregnancy between RH positive husband and RH negative wife is going to be showing the consequences which lead to HDNB or HDN, which is also referred to as erythroblastosis fetalis. Erythroblastosis fetalis. Let's see what do you mean by this. Hemolytic disorder of newborn. That is during the pregnancy, the fetus prone for rupture of the RBCs or erythrocytes. That's what erythroblastosis fetalis. In the fetus, the RBCs are ruptured because of the clotting. Why clotting takes place? as it is the genetic incompatibility, no existence of two different blood group. Why? Positive, negative results in the genetic incompatibility lead to HDNB or HDN. Thank you. Now let's see what is this consequences. So Rh positive blood if donated to the, so blood transfusion, and the two consequences I told you, they are abnormal blood transfusion and the pregnancy are the two conditions which results in the genetic incompatibility lead to the second, the pregnancy prone for HDNB. The first condition is blood transfusion. For suppose if a Rh positive blood, if Rh positive blood donated to Rh negative individual, let's have the first description. If Rh positive blood transfused to Rh negative individual who are earlier do not have any blood transfusion, so Rh positive blood, in the sense they are with the Rh antigens. When this is introduced into the recipient Rh negative, the recipient individual immune system sensitizes and produces the Rh antibodies. These are nothing but the IgG type. I repeat. So this is the first instance where the blood transfusion, how it is harmful, is now we are going to discuss. So Rh positive blood when given to Rh negative individual. So in the Rh negative individuals, the Rh antibodies are produced. I already told you that Rh antibodies do not exist naturally and are produced when a recipient of Rh negative receives the blood from Rh positive donor. So here the Rh antibodies, they are of IgG type. Earlier I informed you there are the immunoglobulins antibodies are of IgA, IgD, IgE, IgG and IgM. IgM antibody A and antibody B present in the blood plasma are of IgM type. That also we have discussed in the ABO blood grouping system. Now it is IgG type. So the Rh antibodies which are smaller comes under IgG type, and these Rh antibodies go on producing this lead to Rh antigen and Rh antibodies. This results in a clumping, that is the RBCs red blood corpuscles are ruptured. This is the consequence we see. RBCs, red blood corpuscles in the recipient will be ruptured when the same individual, so first time exposure to Rh antigens blood group, the recipient first time the immune system sensitizes and produces Rh antibodies. So second time if it happens to be with the same Rh positive exposure, already sensitized immune system produce a large number of Rh antibodies, and this is going to be rupture the RBCs. This is what the first possibility of prone for the rupturing of the RBCs, and it leads to anemia. The reduction in the number of RBCs is named to be the anemia, so they prone for anemic status. Let's see the second importance, second status, second the character, second the feature is pregnancy. Let's come to the discussion. The second consequence pregnancy, if a marriage between Rh positive husband, Rh negative wife, This is results in genetic incompatibility. First, genetic incompatibility, blood transfusion we have discussed. The second is a pregnancy. The husband, male, this is the indication, Rh positive, and the woman is Rh negative. So the Rh positive is denoted as, let's see, capital R1 and R0, or else capital R1, capital R1. Homozygous dominant, and the recessive is nothing but double recessive Rh negative. So what is the probability of the child first to be born? Is heterozygous. So he is also Rh positive. Is it right or not? The baby born, first baby is Rh positive itself. This is the Rh positive father and Rh negative mother, which is denoted as homozygous, Rh positive and recessive mother. So the baby, what are the possible the alleles in the progeny? Capital R1 and small r. This is the Rh positive. Next, this is the first baby. Diagrammatically I can show you. Look at here. This is a mother immune system, for suppose mother, and this is the fetus. The fetus is connected to the mother by means of the placenta. Look at here. This is the fetus. Fetus, that is a woman. This is the fetus, where the baby is growing. Baby is with the Rh antigens. Rh antigens are present in the baby. Baby born is Rh positive. We know very well that is among all the mammals, there is an intimate associated structure between the mother and the fetus. Mother and fetus are connected by means of a intimately associated structure named to be the placenta. This is the placenta. So the first baby born is Rh positive. These antigens are what? When the first baby born, while birth, the placenta ruptures. The contact between the mother and the baby fetus by means of the placenta ruptures. Naturally, the Rh antigens are released into the bloodstream. So Rh antigen is exposed to the mother immune system via the blood. So mother immune system sensitizes and produces Rh antibodies. Rh antibodies are produced. Rh antibodies are produced. As Rh antibodies are produced, this sensitization process of Rh antigen meeting with the mother immune system and the sensitization of mother immune system and producing Rh antibodies, the baby what take birth, which means, look at here. This is the diagram showing the placenta rupture and the baby take birth. The baby birth, baby born. So before the sensitization of the mother immune system, the first baby born. So the first baby is Rh positive but harmless. As in the case of the earlier we have seen in the blood transfusion, the first exposure to Rh antigen is harmless status. So the first baby take birth normal. Let's see, this is the first pregnancy between the Rh positive father and Rh negative mother. The second pregnancy, look at here. Look at here. The description, what it indicates. The baby is with RH antigens. RH antigens are there. RH antigens. And the mother sensory system to which basically mother's sensory system already intimately connected with mother is connected to that of the baby by means of placenta. Placenta is a connection between the mother and the fetus through which the exchange of nutrients what takes place. Since these RH antibodies are smaller, they also diffuse and reach the antibodies what reach the what is called the fetus. Look at here. The diagram that I am drawing indicates the RH antigen and RH antibody. This RH antigen and RH antibodies, second exposure, the second baby born is with RH antigen naturally, as the parents are RH positive father and RH negative mother. These RH antigens expose it to the sensitized mother immune system. RH antibodies go on producing. One thing remember, I told you that agglutination is as against the donor antigen. If the recipient antibodies are produced more, it leads to clumping. So the donor antibodies, recipient antigens are less important, I told you. Recipient antigen and donor antibodies are of less important, but here donor antigen and recipient antibodies are go on producing. As antibodies go on producing as against the antigen, so it leads to the rupture of the RBCs. This leads to the rupture of the RBCs, a condition named to be the HDNB, hemolytic disorder of newborn, that is during the developing condition itself, during the fetus level, the baby born, hemolytic disorder of the newborn at the fetus, or else even after the birth they face the consequences of the anemia, which is during that also after birth also they prone for the same condition, which is named to be the hemolytic disorder of newborn, or else erythroblastosis fetalis, fetalis. So that's the reason why RH positive father, RH negative mother, a marriage between RH positive husband and RH negative wife is genetically incompatible and it is not suggestible, whereas vice versa is different. If the woman is RH positive and husband is RH negative, it is suggestible. Thank you.